question, so I'd really... The first thing you're going to notice is it wants the trapezoidal rule, okay? And the x values are 1, 2, 3, and 4. So the trapezoidal rule is basically... The trapezoidal rule is h over 2, firsts plus lasts, 2 times the remainder. Now, does anybody know what page this is on in your tables? It's under area approximation, isn't it? Anybody actually know? You speed me up there. It's page 12. Okay. And what you'll notice on this is, oh, there it is there. That's the formula they have. Now, you'll clearly see y1 is your first, yn is your last, and 2 times everything else. So first plus last, 2 times remaining. It doesn't actually say that in your notes though, it just says this equation here on page 12. Okay, just so we're clear upon that. Now, next thing. You're going to need a set of x and y values to make this work. Okay, because you need to find each height. Now, it's log base e. What's log base e otherwise known as? We'd hope you'd all know it as ln. Log base e is otherwise known as ln. So, essentially, 1, 2, 3, and 4. The x value, that means the y value would be ln1, ln2, ln3, ln4. The h value is your width. It's called area approximation because it's not 100% accurate, but it's pretty close. So what we're going to do is ln1 is actually 0. So it's going to be 0 plus ln4, and then 2 times your remainder, which is your ln2 plus your ln3. Throw it all into the calculator, and you get... Oh, sorry. You're not to throw it all in the calculator. Can I explain why? It wants it left in log form, so you're not allowed to throw it all in the calculator. My bad. So we're going to have to do some log rules, I'm afraid. Good old log rules. ln4. What's ln2 plus ln3? Multiplication rule of logs. So addition rule means you multiply them. So what's 2 times 3? Anybody? ln6. Does anybody remember the power rule of logs? Okay, we'll probably need to give you a quick revisor here. Can anybody tell me what log 5 plus log 7 is? Log 35. Great. Can anybody tell me what 2 log 5 is? Bring the 2 in here and square it and you get log 25. Is that okay with you guys? So what do you think 2 ln6 is? Bring the 2 in there and it's ln6 squared, which is? Anybody? 36. ln 36. Now, what's ln 36 plus ln 4? Anybody? 4 times 36? 144. And once again, what am I going to do with that half on the outside? Bring it to the power. And ln 144 to the power of a half? ln 12. ln 12 in your calculator. Yeah, I'll just write it down for that's your answer. That's full marks. But I'm going to go for 2.485, okay? That's roughly what it sums up to. Everybody cool with that? Any questions? Yes?
You have to change it back into logs.
I already have it in logs. That's my answer. I'm just writing, I said, literally word for word, I said, I'm just writing this down just to give me a rough idea of the size of it. So, ln is a log. Yeah, I also said that earlier, that log base e is ln. Word for word. Okay? Shh. Now, the actual you want the actual area of the region enclosed, okay? So, this is going to be... Shh. So this part 2, yeah? So, you want the actual area of the region enclosed. So I'm just going to get rid of all this, and I sort of want to do it here. Now, actually... idiot. What I'm just going to do is just going to take a screenshot of the diagram because I want the diagram essentially. Okay, current page. Give me you. Now, cut. Now, I'm going to explain. This was sneaky. It was excellent. It was great, but it was sneaky. All right. So sneaky. Now, find the actual area of the region. It wants this area here, doesn't it? And we know the answer has to be pretty close to ln12. It has to be around the 2.5 region somewhere. Everybody cool with that? We have an approximation, which means we know where our answer is going to lie. Now, part of me goes, no bother. It's the area of 1 to 4. And it's the y value, which is ln x, isn't it? The x. That's easy. That's what we were worrying about. I'm just going to go to the integration. Where's integration again? 34, is it? 25. Alright. No bother. I'm going to go to the integration section. And we'll just integrate this and deadly. ln x. ln x. ln x. Oh crap. I've never integrated ln x in my life. Kenny has messed up. It's his fault. It's over. Can't do this question. Okay, everybody agreed? So, alright. So, the yellow region, and I actually, when I was doing this at home, I was like, oh, that was interesting, and then I remembered the other thing. So, the yellow region is the integral of y dx. That's when you pin it to the x-axis. You could get the area of the blue region instead, and get the area of the rectangle. I don't know if did anybody do this? Get the area of the rectangle and take away the blue region, and you're in business, right? So instead of using y dx, what you're going to use instead is x dy. All right. Now here's the other problem with x dy. You can't use x values. You need to use values from the y-axis. Where does the y-axis start, lads? 0. And when x equals 4, what's its value? ln 4. This value is ln 4. So you have your two values now. You have that's 0, that's ln 4. Now the only thing that remains is, can you get x on its own in terms of y? So currently we have y equals log base e x. Everybody cool with that? Now, does anybody remember how logs actually work? Okay, let's give you a quick revisor here. Shush, right? Quick revisor. Can anybody tell me what log 8 base 2 is? Without using your calculator. How many 2's does it require to multiply to make 8? 3. And here's the rule. This number here, blue, on its own always equals yellow to the power of green. Does everybody see that? Blue on its own always equals yellow to the power of green. Doesn't matter what's in there. It's always that way. So 8 equals 2 to the power of 3. Would everybody be happy with that? Now, using that same logic, okay, the same logic we just used a second ago, okay, I'm going to put the y over here instead. Okay? Yellow on its own, oh sorry, that's clearly green. Yellow on its own equals green to the power of blue. No bother. X on its own is e to the power of y. So what can I turn x into? E to the power of y. Now, I'm going, fingers crossed I can integrate this. I go to my tables. Can I integrate e to the y? Yes, I can. It's the same as e to the x. I'm in business. Okay? So, next thing I do is, what happens when you integrate e to the y? Just e to the y. And it's ln 4 and ln 0. Now, we're just going to do e ln 4 minus e0, yeah? And the answer is 3. This is an area of 3. The blue area is area 3. Now, has anybody in the class know how to get the area of the rectangle itself? Length by width, isn't it? There's your length, there's your width. 4 times ln 4. What?
We don't divide, it starts at 0.
No. 1, 2, 3, 4. Okay, now, length by width, or length by height, which is 4 times ln4. Sorry. Alright, 4 ln4. I should have it here anyway. Lads, to be honest, I wouldn't even get that because I'm going to take 4 ln4, take away 3, haven't I? Lads, to find the yellow area, it's 4 ln4 take away 3, and 4 ln4 take away 3, and that actually turns out to be 2 decimal places. It turns out to be, wait. Oh, no. I almost made a little error there, right? It wants the percentage error to 2 decimal places, doesn't it? It wants the percentage error to 2 decimal places, not the actual area to 2 decimal places. So I'm going to do 4 ln4 take away 3 in my calculator, and I'm going to put in as many decimals as I can bear. The yellow area is 2. You close that door. 5177. Okay, that's enough decimal points that I should get an accurate area. Now, which one's the accurate area? Is this one or the approximation from part A the best answer? Which one's the best answer? This one's the best answer. So, percentage error is error divided by real value multiplied by 100. Now, if you really want, lads, you don't have to round off whatsoever. You could just say that, oh sorry, the error, my bad. To get the error, what would you do? You get ln12, which was the answer of your first part, and you can take away all of this here. Okay, ln12 minus 4 ln4 minus 3. Oh, sorry, 4 ln4 minus 3. The other area was smaller, okay? So it's 0.0603. Okay, and that's my error. Okay, so 0.0603 divided by ln12 multiplied by 100. Divided by ln12 multiplied by 100. 2.43%. 2.43%. Is that okay with you guys? Alright. That was a great little question that you got stuck using the x values, and you need to remember you can also use x to y. That's the key lesson there. If you can't get the yellow one, get the blue one using x dy. That's the key we want there, okay? Now, next one. This one. Oh god, this one, alright? Now, I have to say this one's just difficult for the sake of being difficult. Question 1's really easy. What does initially mean? Lads, what does initially mean? Yeah. Anywhere you see t, replace it with 0. Okay? Now, and the answer will be 10. We're simply replacing anywhere we see a t value gets replaced with 0. Okay? And if you're wondering where that is, it's here and here are the t values, and they got replaced with 0. And that's why the two of them are 0. Okay? Next thing. You're going to get 50k over k plus 16 equals 10. If you don't mind, I assume you can take it from there and get a k value. Okay? And the k value equals 4. Happy days. Right? Once you rearrange, do a linear, you get your answer. K is 4, right? You can take it from there. Now, the formula now becomes the following. NT now becomes, so it's 50 times 4, and 50 times 4 is 200. Anywhere there's a k, see the k's? I'm replacing the k's with 4. Okay? So that's why it's 200 e to the 0.5t. There was a k on the bottom here, which means that's 4 e to the 0.5t plus 16. I've redone my equation, except I've inserted the k value as 4. Is that okay with you guys? Now, what does it say it wants from me? T value of 8 years. Oh, this is handy. This is easy money at the moment. Okay. What's a half times 8? Huh? 4, isn't it? So it's 200 e to the 4. 4 e to the 4 plus 16. Throw all that into the calculator. You'll get 47 to the nearest whole number. We all good? All right. Shh. Once again, who did this question in the exam? Did you get that part out? Good job. Right. Next part. Now, shh. 200. Shh. There's a hint in this question. I'd imagine this is the part where you didn't get it anymore. Right? That's okay. That's sort of to be expected, alright? Now, just because you don't get this part doesn't mean you can't attempt the next part either. Right? That's the good news, alright? So what's this point? Well, actually it does. Never mind. Sorry. Lads, if I was in an exam, can I give you a hint here? If I was in an exam and this was my, I was looking at this question and I was going, I haven't got a hope, right? I've just admitted that to myself. I can't do this, right? And then I'd look at the next question and go, right, it uses n of t, alright, and then in part 5, okay, now the truth is, you would need the dumbed down version, okay? So you could, in theory, if something like this ever happens to you, just go, grand, and then just use those values for the next question if you want, alright? You could do that. Yeah. And then you're able to attempt the next questions using the wrong answer from part 3. Do you get what I'm saying? You could show that you know the method for the next question by using those numbers, so you can pick up marks anyway. Alright? And they'll just punish you for no marks here. And then they'll say, well, using the values you got. Now, that's if you're desperate, it's worth doing. Okay? Now, let's do what I'm doing. Lads, there's a hint here. Here's the hint. Okay? Shh. I want to show you how I came to this conclusion. Alright? See the way A and B are an element of n? This means that this yellow part turns into a natural number, which means the e part disappears. And also the real hint is, see the number 1? That turned into the number 1. Do you see that? So if that turns into the number 1, here's what I'm thinking. You must have divided it by itself. And if you divide that by itself, you have to divide everything else by the same number. Okay? And see the way I'm dividing everything by that number? Oh, sorry. Okay? Everybody ready? Now what happens? Cancel, cancel. 200 divided by 4? 50. Okay? And can everybody then, what's it divided by itself? 1. What's 16 divided by 4? 4. And what's 1 over e to the 0.5t as a negative power? The answer's already here. E to the minus 0.5t. I'm going to pause there. Alright. I don't think it's quite worth the time that I need to put into it, but I'll do it anyway, and I'll show you. So I'll do the first part and I'll explain how to do the second part, okay? Now, here's what it is. See NT, okay? We just said that NT is this here. And that's a lot simpler than the equation they gave us in part A, isn't it? part A's equation was a lot more difficult. So I'm just going to write down n of t is 50 over 1 plus 4 e to the minus 0.5 t. Cool with that? Alright? Now look at this. Show that the rate of growth of the number of strokes. What does rate of growth mean? Rate. First derivative. You're going to have to differentiate this, okay? What rule would you differentiate this with? Yeah. Okay. Now the VDT, lads. Differentiate 1, you get 0. Differentiate e, you always get the same power, don't you? But what's the catch? You differentiate the power. And what happens when you differentiate this power here? Everybody agree with minus a half? And what's minus a half times 4? Okay, you cool with that? Now, long story short, you're going to throw all this into the, you're going to throw all of this, so this is phi times the UDT, which is 0. In that case, I don't need to write it down, do I? Because it's 0, so to hell with that, okay? And then minus u times the VDT, or u times the VDX, so to speak, is minus 50 times this guy here, isn't it? It's minus 2 e to the minus 0.5 t, and then what's that all over? This one squared, isn't it? We cool? Alright. Now lads, you listening? Okay. You just multiply the top out and you get 100. You just get 100 e to the minus 0.5. Okay. Okay. And you're sort of going, this looks nothing like this. Agreed? Absolutely nothing like it. Alright? Now, here's where part 2 kicks in. Okay? You're sort of saving this answer. See this answer here? The 100 over... you're just going to save that for a minute. Okay? And I actually had to go back to the end of the paper to finish this off. It's just turned out to be such a basically a colossus of algebra that I don't think I'll quite do it all today. You can use the marking scheme. The marking scheme does it pretty good, alright? But here's essentially what you do. You sub in your NT value. Anywhere you see NT, sub it in. Okay? And here's what we'll get. So what's NT divided by 100? So what happens if I divide all this by 100? If I put 100 on the bottom, what happens to the 50 and the 100? Can anybody tell me? 50 turns into 1, 100 turns into 2. Excellent, alright? So that would make this part, the first part here in the red box, that will be 1 over 2, 1 plus 4, e to the 0.5 t. Cool with that? Now, the part in the blue box. Everybody ready for the part in the blue box? The part in the blue box is 50 take away this. And 50 take away this is actually, I'm going to give them a common denominator. The common denominator being this guy here. Okay? And from here, you can see that the 50s cancel, can't you? Does everybody see that the 50s cancel? 50 times 1 is 50. 50 times 4 is 200. E to the minus 0.5 t, and then you have minus 50 on top. So the 50s cancel. Beautiful. And it's 200 e to the minus 0.5 t, and now it's all over 1 plus 4. It's fantastic. Great for my concentration. Stay with me, guys. Long story short, 200 divided by 2. 200 divided by 2? 100. This one multiplied by this one, they're exactly the same. So what does that mean? And it's exactly the same answer we got in when we differentiated it. Now, this one here, all we're going to say is not a chance in hell. Alright? Just awful. Alright? Once again, have it done. But, alright, we'll just, the language is the key point here, right? They won't give you anything this difficult in the leaving cert. The language is the key, right? So the only thing I really want you to take home from here is the language. Hence find the number of shrubs. Hence find the number of shrubs in the garden when the rate of growth is at its greatest. When the first derivative is a max. The first derivative is a max. Alright? Or the equation in part 4. Is this the equation in part 4? Sorry guys, does everybody see no, I'm on the wrong question. Oh yeah, that's the back. That makes sense. Yeah. Alright, lads. So, 4 will show the rate of growth. Does everybody see the rate of growth? And this is my rate of growth equation. No bother. Match up the language. Rate of growth equation, 100. And this is actually the legit answer in the marking scheme as well. So it's not just Kenny gone crazy, I guarantee you. Even though after doing this mock, you would not be, you'd be not giving out if we're going a bit crazy, alright? And now, get this. You ready? When the rate of growth is at its greatest, means its maximum, which means differentiate that again and put it equal to 0. So this is the first derivative. You're getting the second derivative and put it equal to 0. You're going to have to put this as u and this as v and do yet another quotient rule. I will not waste your time doing this. You can attempt it using the marking scheme if you want. Alright? And long story short, what did we get at the very end? You're going to differentiate that. You're going to put it equal to 0, and you're going to find a the variable for the number of shrubs. Okay? Just no point. Is that alright, guys? It's a quotient rule using those two numbers, alright? I won't engage with it, it's too much time. Okay, next one. Area of the free surface. Alright? See the triangle on the top? What can I cut that into? Cut that into 2/30s. The free surface is this little area here. That's the surface of water that's at the top, which can change depending on how much you fill it. Okay? And what we're going to say is that its radius, which is r, right? We're going to say that opposite over adjacent, isn't it? So tan 30 is r over x. That means x on its own is r over tan 30, and r over tan 30 is, what's 1 over tan 30? Yeah. Sorry. Sorry. It wants r in terms of x. My fault. R equals x tan 30. My fault. And x tan 30. Some people will get r equals root 3 over 3x. Other people will get r equals 1 over root 3x. Both answers are correct. I prefer to use the bottom one because it has a number 1 in it, and I think that makes me faster. Okay? Nextly, everybody on board so far? Okay. Find the volume of the empty space in the vessel. Well, lads, that's a cone all day long, isn't it? It's a cone of air. Would you agree with that? So it's a third pi r squared h. Now it clearly says in terms of x, so I need to use my answer from the first part, which is 1 over root 3 x to be squared. What's the height of the cone? X. Throw it all in the calculator, apart from the x's, and you'll get pi x cubed over 9. So you throw that into the calculator, this part here and this part here into the calculator, you'll get pi over 9. Okay, everybody on board so far? Alright, part 3. Of course we will need the diagram on every page. Okay, find the rate at which the level of water in the vessel is rising when the depth is 5 centimeters below the apex. Whew. Lads, please zone in on the language here, alright? Really want you to be zoned in on the language. Rate at which the water level in the vessel is rising. Rate at which the water level in the... Is that not the x value, is it? That the x value is getting smaller? The height of the cone is getting smaller? So would that not mean we're after dx dt? That's what that means. We're after dx dt. The height is decreasing. Okay? Because the water is rising. Okay? Now we have to make some sort of equation. What does it tell us in part 1? The volume is rising at dv dt is what, lads? 10. Would that make sense? Okay. What 2 letters do I need here to make this work? What cancels the dv on top? A dv on the bottom. And what do I want? I don't want to cancel the d, do I? So what do I want? A dx. Now, we have v in terms of x, don't we? We have v is pi x cubed over 9. What happens if I differentiate this? What do I get? I get the v dx. 3 to the front. Okay? How do I turn the v dx into dx dv? What? Turn it upside down, isn't it? By the way, the 9 and the 3 sort of turn into a third. Turn it upside down. Okay? No bother. Now what do I turn all the x's into? It gives me the x value. What is the x value? Everybody see it? 5, isn't it? Six over 5 pi. What is it? 6 over 5 pi? Sorry, 1 second. Oh. Sorry. Sorry. Lads, sorry, the VDT was 3 over pi x. Sorry, that's what I got for dx dv, wasn't it? What did we say the VDT was again? 10. Dx dv is 3 over pi x squared, which is 3 times pi 5 squared, and that's 6 over 5 pi centimeters per second, okay? Hence find the rate at which the area of the free surface. What is the area of the free surface? Looks like an area of a circle to me. Would you agree with that? Area of free surface is an area of a circle. Okay. Now, there's the area of your free surface, okay? The rate at which it's decreasing, that's dA dt, isn't it? The rate at which the area is decreasing is dA dt. So we'd say dA dt equals, now here's the tricky part. If I use dA dr, never mind. I'll finish off tomorrow, lads. That took